We are all welcome to this class, and it's going to be a quick one whereby we will also discuss linear differential equation and also what are the things do we need to know, aspect of it, method of undetermined coefficient, undetermined coefficient. So we will look into that, and from then we move on. Let me quickly share my screen. So now, if we are this kind of question, how do we resolve them? What are the things is expected of us? If you want to read the topic, you can read from the manual. We have a lot of questions are there, but let's still proceed with this what we have and see how we can also be of help to one another. Please write for those of us that are online, while others will join and also write later. So when we have a differential equation of this form, for example, if you have ax, or let's say y, let me use y, ay prime prime plus b y prime plus cy equals to g of x. So how do we write the solution of this kind of form? When I say ay prime prime, what does it mean? Can anybody explain to us? If you want to talk, raise up your hand, please. What does a prime prime means? Ay prime prime, what does it mean?
As a double integration.
Differential equation. You have to differentiate twice. So from the knowledge of our calculus and the one we've been solving. So now, for us to write this particular equation out, we have general equation to be y equals to yc plus yp. What is yc? Yc is complementary function. That is, when you are writing the complementary aspect of the work, some say complementary solution or function, while some also say this yp is particular solution or function. So by the time you add the two together, it becomes the general solution of this form. So I will just give us the summary, but there are some things that are always difficult at this point. How do we know the g of x? How do we identify the g of x? Let's say we have g of x. Let's say we have form. Let's look at this form of g of s, that can occur because we actually use g of s to solve the old issue here, the old problem here. So then form of y particular, that is yp. So if you have a constant, let's say we have a constant, who can give me example of a constant in this case? Let's say you have a value, probably 25, 30, where you are given an equation and you have a constant. So that is what we are talking about. If you have a constant, what is, for example, if I have equation like this, let me just give us equation. Let's say I have number 1, y prime prime plus 3y prime plus 2y equals to 5. This is a constant in this case, right? So how do we represent it in Y particular? You represent it as what? A. Let's take note of that. But when your problem you're given is a linear polynomial, please take note of this. Our YP, form of YP we use will be AX plus B, because we actually substitute our G of X. Look at this now. Let's say my G of X, what I'm saying is, if my G of X is constant, I will represent it by A. But if my G of X is linear polynomial, I will represent it as AS plus B. Please take note of this. Then, if I now have a quadratic polynomial or equation, so my YP will be AX squared plus BS plus C. Are you following? Then, if I have a cubic, for example, a cubic polynomial, I will have AS cubed plus BS squared plus CS plus E. Then, if I have a sine, let's say sine AX or cos AX. So what I'm going to use will be A cos. Okay, let's call this one alpha so that you win cos alpha S sine alpha X. Call this one, you will now be A cos alpha X plus B sine alpha X. Alpha X can be probably sine 2X, sine 3X. So don't forget. But in case we now have exponential formats, if exponential is exponential alpha X, so it's going to be A exponential alpha X. But in case you have another value beside the alpha or behind, let's say you have your X is different or your exponential is different. How do we write it? Some exponential can carry AX alpha and continue like that. So that one will be AX exponential alpha X. So we have different things that can come up when it comes to this particular question. But by the time we are solving some of the problem, we will understand better and you will also know what it means. Okay, let's go. Let's proceed. Let's take this one as example 1. Any question, please?
No question,
Please,
sir.
no question. Okay, please take note of this table. We'll be going back to the table. Okay, let's look at this example 1. Now, for this example 1, what do we need to do? First thing is to represent it. For example, I can represent this one by R, or I can represent it by M. It depends. Let's say I have R squared, because this is second derivative, right? That's why I put R squared plus 3R and plus 2 equals to 0. I want to solve it now. I really want to solve it so that it will give me That's why I said, for those of you that are joining us, please go and watch the previous video where we talk about integrating factor, how do we derive it, where we talk about homogeneous equation and non-homogeneous equation. Please go and check it. It is very important because we are going to be using it now. For example, that's where we get our Y complementary. Is there? I think I still have some of them here. Let me just quickly branch it so that you will understand where we are coming from when we are talking about it. They are there on your video, and all you need to do is just to take your time, watch the video, make your notes out of the video, so you can also be part of what we are doing. So initially we talk about integrating factor. This is exact solution. Now, let me just quickly say one or two things there, like we are talking now, so that we can also be part of it. So this is homogeneous. Now, you need to first of all get Y complementary, Y complement. Okay, at this point now, this is what we do here, where we substitute for C for exponential. Okay, I think we did something similar also here. Okay, let's look at this. Okay, look at this one now. This particular question, we are given, they said y, dy dx is equals to 2xy. So in this case now, what do we do? What we do in this case is to first of all multiply both sides, and at the end of the day with ds we have to separate them. So the y goes to y divided by this, we have this, and by the time you divide both sides by y, you have this. Now we already do what we call separable variable at this point, so which we will not go again when we are going to the new topic we are doing. So we integrate both sides. We have ln y equals to, 2x squared over 2, and we divide by. Then at the end of the day, we take the ln exponential of both sides. So we have this. This is what we call y complement, or y the complementary solution. This is what we call y complementary solution. But for us to get C, we are given, in this case, we are given initial value here. So we have to substitute this initial value into this place. That is, when s is equals to 0, what happened to y? Our y is equals to 3. So we substitute it here to get our C. So at the end of the day, we have this final solution because we have initial value. So in this case now, we will be using our complementary solution, our y complementary, because of what we are doing. Please take note. This is the general solution, like this one we did. We have a particular solution. You have a lot to learn in the previous video. Please just go on, it's either you go on YouTube, you will see it there, or you go on your course page, it's there. Just help yourself out so that what we are doing today will also be part of what you are learning. So that some of us that have missed the classes, you'll be able to catch up on time. So let's move on the topic we are solving. Let us move on, please. So on this case now, we have, like I told you, we represent the y prime prime by r squared, and we represent, just for us to get our y complementary. So when we get y complementary, then we move on. So let's take note of that. So sorry to take your time just to explain to some of us, so that what I'm doing will not be like a Greek to you. Okay, let's move on. So in this case now, we have this. How can we break this one down? You agree with me if I said r plus 2 and r plus 1 equals to 0. Our r in this case is equals to, our r in this case is the same thing as r plus 2 equals to 0, or r plus 1 equals to 0. Then our r in this case is minus 2, or r is equals to minus 1. So then our y complementary will be, y complementary solution will be C1 exponential. Remember, on a normal day, it's supposed to be AS or alpha x. Let's say C1 exponential alpha x plus C2 exponential alpha x. Now, don't forget, two things happen at this point. Because our solution is a quadratic solution, so that's why we have two. If it is not quadratic solution, we only have single one. Now we only have just C1. But now that C1, we have 2R in a quadratic way, then our C will be, substitute this alpha represented by what? Your R. We can say C1 exponential. What is alpha? -2. Or you can start from -1 and say minus. When you substitute -1 here, it will be -x plus C2 exponential -2x. So in this case now, what do we need to do? Let's go back to that is our y complementary. Call it. But the generalized solution is y equals to yc plus yp. This is our general solution. This is where we are still coming from. So now let's look at the yp. Yp in this case, remember I told you, it is yp leads to g of x from the definition we have here. Look at this. From the definition, g of x. What is our g of x from this equation? Hello? Our g of x is equal to what?
5.
5. Thank you. So our g of x is equal to 5. Equals to 5. Then what is our yp will be now? When you have a constant. Are you following now? Because this 5 is constant. There is no variable attached to it. No s, no exponential, nothing.
Okay.
So is what?
A.
Thank you. It's going to be A. So now what we need to do is we will differentiate yp first time. When you differentiate yp first time, what do you have? When you differentiate constant, what do you have?
0.
Thank you. When you differentiate it second time, because we have yp, we have double prime, second derivative. When you differentiate it second time, what do you have? Differentiate yp prime, differentiate 0, what do you have again?
0.
0. Thank you. You said what?
Never
0.
mind.
Okay, now what you need to do is go to your question. Let's call this one equation 1. Equation 1. So let's go to equation 1. Substitute yp into equation 1. Substitute yp into equation 1. So we write equation 1 becomes, what is equation 1 becomes? So y prime prime of particular solution is what? 0. Let's write equation 1 again, because some of us are looking y prime prime plus what?
3y prime. 3y prime
3y prime
plus
Plus
2y
2y
okay,
is equal to 5.
equals to 5. Thank you. Now, equation 1, that's our equation 1. It will now become, you substitute your first derivative, and second derivative there, and when you have y, you substitute it inside the equation 1. You can write a short notes in your own way, the way you can understand it when you are studying. So substitute y p, y prime p, and y prime prime p. So it's going to be y prime prime p is what? 0 in this case, plus 3 of 0 plus 2 of what?
Yes.
A, thank you, equals to 5. So at the end of the day, we have 2a equals to 5. What is our a?
2.5.
5 over 2.
5
Over 2.
over 2. Thank you. So it simply means that our yp is equals to 5 over 2. Don't forget from here, yp is equals to this, and yp we call it a. And our a is equals to 5 over 2. So that's why we can boldly say that our yp is equals to 5 over 2. Now, is that all? No. You have to go to the general solution. Our general solution says y equals to yc plus yp. Now, we can substitute it now. What is our yc?
C1 exponential minus x plus C2 exponential minus 2x.
Thank you. Then what is our yp?
5 over 2.
That's all. That is the solution they ask you to find. When you are given in exam, find the general solution. This is the general solution they say you should find. And anytime you are given, once you see the question like this, that is the method they said you should use. Nobody will tell you, go and use this. You must know this table offhand. Write it out again and again in your own way. Any question? Let's solve another one. Okay, I will try and keep my left my left side of my equation. Let's say number 2 now. I will still use y prime prime plus 3y prime plus 2y equals to 4x plus 5. So what category can we call 4x plus 5?
Linear polynomial.
Linear polynomial, thank you. So that means let's call this one equation 2. Now we have it linear polynomial, but you agree with me that I can say that r squared plus 3r plus 2 is equals to 0, where my r is the same thing as minus 2 or r is equals to minus 1. Do you agree? Do we agree?
Yeah, are we trying to refer to the first equation?
The same, yes, you are trying to find the y complementary now. So,
Yes, sir.
so the same y complementary we are going to have, but only that our g of x will be different. So we have y complementary to be c1 exponential minus this plus c2 exponential minus 2x. So now, in this case now, we need to look for our g of x, which is same thing as 4x plus 5, which implies that our yp, what's the definition for yp for this kind of g of x? Anybody?
Ax plus b.
Ax plus b, thank you. ax plus b. Now, the question is, we need to differentiate. Now, yp prime is equals to what? When you differentiate this one with respect to yp prime, what do you have? You have what? A. Because this is x will be what? 1. 1 multiplied by a. Then when you differentiate constant, what do you have? 0. Any question? Then yp prime prime, when you differentiate a, what do you have? 0. So what happened to our equation? Our equation 2 becomes what? Remember, we have y prime prime plus 3y prime plus 2y equals to what? 5. Equals to 4x plus 5. Sorry. Are you getting it?
Yes, sir. I'm with you. Hello, sir. Yes, we can hear you.
Okay, thank you. So, like we are doing now, let's continue. Let me share my screen again. Okay, we have this. We can as well try to link it up. So let's substitute our value into it. Y prime prime is what? 0 plus
0.
3 of what? A plus 2. What is our y?
Ax plus b.
As plus
B.
b. Okay, equals to 4x plus 5. So at the end of the day, we have here 3a plus 2ax plus 2b equals to 4x plus 5. Sorry, kindly mute yourself when you have a noisy background so that we can all hear ourselves. Now, at this point, we need to compare what we have in the, let's try and match which one contained with x, which one without x. It will represent what we have here. Anyone that contains with x will equals to this. Anyone without x will equals to this. So that is what we are saying. So let's look at it. Which one with x? Let's look at this.
2x.
So we have 2a in bracket x plus 3a plus 2b. Are you getting what I'm doing now? Everything equals to 4x plus 5. So the one with x will now be, we have it to be what? 2a equals to 4. Do you agree with me?
Yes, sir.
Please talk.
Yes,
If
sir.
you know you don't understand what I'm saying.
We are getting it, sir.
No, sir, can you just come back? I didn't get that. I didn't get that.
You didn't get it. Okay, good. Thank you.
Yeah.
Now, what we are saying is, look at it. We have 2ax, and now pick 2ax out. 2ax out. Which one has x in this value? You see is 4x. We are trying to get the unknown, all these we are using coefficient to map coefficient. That's why the topic said method of undetermined coefficient. So we are trying to match them. That is, anyone that contains x, let it equals to the one that contains x. Anyone that contains x squared, let it equals to the one that contains x squared. Anyone that contains constant, let it equals to constant. That's what we are doing. Now, you discover that from this equation now, we have 2a in bracket x is out. The other one, they do not contain x. That's why we collate them together. Now, it is easier for me to now say this is equals to this. This is equals to this. Why this, gentlemen, they are equals to this. You remember 5 does not have x. So 3a plus 2b is 2. They don't have x. That is what I did. And it's part of our method we use in mathematics. So now let's link them now. Or if you want me to write it out, you can still see that. I can say 2a x equals to 4x. X cancel x. Do you agree?
Yes.
You agree now? Okay. Now, let's continue. I can now say that I can find my a now. I can say 2a equals to 4. What is my a?
2.
Yes. My a is equals to 2. Then don't forget the second one. It says 3a plus 2b equals to what now?
5.
Equals to 5. Thank you. Then don't forget, you know your a. Substitute your a. So I have 3 into 2 plus 2b equals to 5. I have 6 plus 2b equals to 5. Then my 2b is equals to 5 minus 6. 2b is equals to what? Negative 1. Okay. My b is equals to minus 1 over 2. Do you agree?
Yes, sir.
Yes.
Okay. Now let's go to, that means our yp now is equals to, what is our yp?
Our yp.
You can see it's
2. Yp is 2.
Really?
Yp.
Yp,
our yp is ax plus b, now.
Is what?
Ax plus b.
Ax plus b. That's our yp. Yp is as plus b. Thank you. Look at it. As plus b. Now, let's now substitute the a and substitute the b. What is your yp now? Please mute yourself.
2x minus that.
2x minus 1 over 2. Do you all agree now? Remember, your yp is as plus b. And you are able to solve for a and b. So we have it to be this. Now, our general solution will be y equals to yc plus yp, which is the same thing as c1 exponential minus e plus c2 exponential minus 2s plus 2s minus 1 over 2. That is your general solution. Any question? Remember, I'm just explaining, trying to test when you have different functions of what we are, of the table we have up there, of this particular table. Now, we've solved 2 now of this table. We've solved this, we've solved this. Let's look at this. When we have one of these. So in case you are given this question, how do you solve it? In a quadratic format, The same way you solve the one of quadratic will be the same way you solve of cubic if you have cubic question. So let's look at number 3. I will still maintain this side. You see this particular side does not matter. It's only that it will change your power of exponential, that's all. But I have other questions that we can solve on that, but let me just maintain this to solve for what we have now before we move into another one. If time permits us, we will check. If not, you guys will also lay your hands on some of those things. So we have plus 3y prime plus 2y equals to 2x squared plus 4x plus 5. So we still have our YC. I may not write it. Let me just write the YC. Okay. For the purpose of those that are joining us, we just have our Y. This is what YC is. We get our YC from here, and this place is a G of X. So for us to get this, we represent this one. I said, let's say we call this one R squared plus 3. Remember, this is Y prime means R. So when you have Y prime, you have R squared. When you have 3y prime is what? 3R plus 2, because our 2 does not have Y prime. So that's why we call it plus 2. And everything equals to 0. I can go ahead and solve this one quadratically by saying R, like I solved the other time when we are solving, is R plus 2 and R minus 2 plus 1. Everything equals to 0. Your R is equals to minus 2, or your R is equals to minus 1. So, and the formula to put it there is YC, which is the same thing as C1 exponential alpha t, or alpha x rather, alpha x plus C2 exponential alpha x, which is the same thing as YC is equal to, what is our alpha? This represents alpha, this also represents alpha because they are quadratic. Y exponential minus 2x plus C2 or exponential minus x. So this is Y complementary solution that we are solving. So we can go ahead and look for our G of X. Now we have the table. You discover that this is a quadratic. Let's go to our table. Quickly go to our table. Anytime, this is the table we are working with. Anytime you have a quadratic polynomial, what do you have? Or quadratic equation. When you have it to be what? This is the form. So it's going to be what? A squared, AS squared. Okay. Let's
BX.
Thank you.
Plus C.
Okay, you call it for me, then I'll write it out for you guys. So now our G of X so we have G of X G of X is equals to 2 what? What's the value, please?
2x squared plus 4x plus 5.
2x squared plus 4x
plus 5.
Plus 5. So this will now translate to YP, which is same thing as what is our YP? AS squared. Yes.
AS squared.
Plus BX.
Plus BX plus C.
Plus what?
BX plus C.
Plus C. Thank you. So now that you have this, you can go ahead and differentiate your YP. So we have yp prime will be what? Can you differentiate yp? Anybody?
YP.
What is yp?
That will be
Yp prime.
Y prime is 4x.
No. Yp, y prime p or yp prime. Anybody to differentiate this?
That
With
is
respect to
4x
x.
plus 4.
Is what?
4x.
No,
plus
we are
4.
not. This is gx. This is yp. Is the yp you differentiate, not gs. GS
Okay.
will only show you the form you are to
1
use.
plus 0 plus 0.
You said?
1 plus 0 plus 0.
Really? No.
Okay.
This is going to differentiate this with respect to x.
Okay.
2ax
2ax
plus b
Thank you. Who is talking now?
plus 0.
Is that Bisola?
Yes, sir.
Okay. So we have it to be, that is what I'm saying is differentiate this with respect to x. This will be 2. When you differentiate 2x squared, you give you 2x. Multiply by a 2ax. Differentiate bx will be b. So now let's differentiate this also. Y prime prime p. Differentiate this again. What do you have? Anybody?
2a.
Thank you. 2a. Remember, you differentiate twice because you have y prime prime. That is why it's prime. Are we together now?
Yes, sir.
So let's substitute into equation 3. Let's call this one equation 3. So equation 3 becomes y prime prime plus 3 plus 3 what? Y prime plus 2y equals to 2x squared plus 4x plus 5. So now let's substitute into this equation. Our y prime prime is what? 2a plus 3 in bracket. What is y prime? 2ax plus b. What is 2? What is y? As squared plus bs plus c. Everything equals to 2s squared plus 4s plus 5. Any question, please? Any question? Okay, let's continue. Silence means no question. So you need to open the brackets one after the other. So let's open this one, 2a plus 2 times this. You have 6ax plus 3b plus 2a multiplied by this. You have 2a s squared plus 2bs plus 2c. Now everything equals to g of x. Now what you need to do is you have to be careful here. Collect the like times. The one that have x squared, let them be x squared. All the value that have x, let them be together. All the value that doesn't have x, which is constant, let them be together. So that's what we're going to do now. So let's look at the one that have x. 2a that have x squared. Have you seen it now? Plus,
Yes, sir.
which one has s ordinary x? Let's collect it. 6a and what?
2bs.
Plus 2b. X will be outside. Are you following? Now,
Yes, sir.
the one without x, we have it to be 2a plus
3b.
3b plus
2c.
Thank you. All of them equates to 2s squared plus 4s plus 5. Now, we will now be solving them one after the other. All the square equated to the square coefficient. So we pick it like I did the other time. Say 2a is equals to what now? Anybody?
Is equal to 2s.
Is equals to what?
And 2 is equal to 2.
Is equals to 2, not 2s squared, because s squared will have cancelled s squared. So it's equal to what? It's equals to 2. So what is a? A is equals to 1.
1.
Because it would have been a is equals to, let me write it again, because somebody will still ask you how. 2 divided by 2, which is equals to 1. Okay. Now, let's go ahead. 6a plus 2b equals to what?
4x.
No.
4.
Equals to what?
4.
4. Because s will have cancelled like I did the other time. Equals to 4. We know a to be 1. So we have it to be 6 into 1 plus 2b equals to 4. We have 6 plus 2b equals to 4. 2b is equals to 4 minus 6. So we have 2b is equals to minus what? 2.
Minus 1.
Our b is equals to minus 2 over 2 equals to minus 1.
Minus 1.
Are we together now?
Yes, sir.
Yes, sir.
Now, the last one, which is our constant, we have it to be 2a plus 3b plus 2c equals to what?
5.
Thank you.
Equal to
Equals
5.
to 5. Now, we have a, we have b. We can substitute them. 1 plus 3 of negative b plus 2c equals to 5. When you open the bracket, you have 2 minus 3.
Minus 3.
2, 5. So this together is what? Negative 1
minus 1 plus 2c
plus 2c equals to 5. Take this one to the other side. 2c is equals to 6. Yeah? Our c is equals to 3. Do we agree?
Yes, sir.
Because this is positive, negative, somebody is still asking how. Okay. We have 5 plus 1 now, which is going to be 6 over 3. 6 over 2. You have it to be 3. So we can go ahead and write our YP. Remember, YP is equals to AS squared plus BS plus C. So your YP will be what now? Anybody? What is our A?
1.
1. 1 multiplied by will be 1S squared plus what is B?
Minus 1.
Minus 1.
Minus b.
Plus C is equals to 3. So when you write your YP now, my YP will be s squared minus x plus 3. So now our general solution can be, let's go to our general solution, yp plus yp. So we have it to be y equals to c1 exponential minus 2x plus c2 exponential minus x. Now, plus yp. S will be what? S squared minus s plus 3. They can give you initial value. I will solve one question on initial value so that you see how they calculate it. So this is our general solution. Any question, please? Now, because of our time, let's move to you can use this method to solve when you have cubic any polynomial function. But let's quickly solve the one with exponential. Or, okay, before exponential, I think I have the one with, okay, let's solve the one of exponential first. I think that one will help us to take note of certain things. So we will be able to know how to solve them. The one of exponential. Are we there now? Can I proceed or we are tired?
You can proceed.
Go on, sir.
You can proceed.
Oh, you mean you are not tired? Okay. So for us to solve this one, how do we, I will just solve one, then we look into it again and to be able to solve others. YP. Let's example 4. Let's say we have y prime prime. How many of us have seen this type of question in our exam? Have you seen it?
No, sir. I have not seen it in mind.
How many of us have seen it before? Something similar like this?
Exam, because
Because there was a time I muted the other time. I'm not sure. Thank you so much. Let's continue from where we stop. So when we have this particular question 4, say y prime prime plus 3y prime plus 2y, so we have equals to 12. Like we did the other time, we equate our y squared, our y prime prime to be r squared plus 3. This is 3r and plus 2y, 2 equals to 0. So when you factorize your r, you have this. You have your r to be -2 and -1. So by the time you substitute, remember that we have our yc to be equal to c1 exponential alpha x plus c2 exponential alpha x. So our x, our y complementary, we have this. So at the end of the day, when you substitute the value, you have what you have c1 exponential negative x and c2 exponential negative 2x. So our g of x will be the same thing as 12 exponential x. So 12 exponential x in this context We also have the form of y particular, which is yp. So it will give us a exponential x. So by the time you differentiate your yp, you have yp in first derivative, you have a exponential x, you have ypp, y prime prime p, you have it to be the same thing. Substitute it into our original question. So by the time we factorize this, so take all the exponential out, equate it to be 12x, 12 exponential x. We get our a to be in this form. Our a will be equals to 2. So having at this point, we cannot go back to our yp. So our yp will be equals to 2 exponential x. So by the time you write your general solution, our general solution in this case will be of, let's look at the general solution. So we have y particular, y complementary plus y particular equals to, we have y complementary to be c1 exponential negative x plus c2 exponential negative 2x plus 2 exponential x. So that's going to be our general solution for this particular question. So in the class work, we have this simple question that says y prime prime plus 3y prime plus 2y equals to the exponential 4x. So at the end of the day, if you solve it very well, like I did the other time, we have it to be, we have to be a exponential this. So when you differentiate your a, what do you have? You have yp prime equals to 4a exponential 4s. Then by the time you differentiate again, you have yp prime prime p will be 16a exponential 4x. So at the end of the day, your a will be equals to 1 over 30. If you solve it very well, then you substitute it into general equation. So, and initially, we have our y complement to be, our y complement for this particular case is what? If our a is equals, your a in this case is 1 over 30, and our y complement is the same thing as c1 exponential negative s plus c2 exponential negative 2x, the way we solved it the other time. So our general equation had everything together. You will have it. So let's move on to exponential problem. In exponential problem, what are the things we need to take note? How do we write our y particulars? The y particular solution in this case is the very key that we need to know. Take note. So let's first of all resolve the complement. The y complementary is r squared plus 3r squared plus 3r. So when we have this, equate it to be 0, factorize it or use general formula. When you use general formula, you have this. Then first of all, do the discriminant aspect of it. Then you have 25. When you find square root of 25, it will lead us into, don't forget this is our r that we are trying to solve. It will lead us into 5. So we have plus or minus. We have 3 minus 3 plus or minus 5 over 2. And by the time you open this, you have negative 3 plus 5 over 2 or negative 3 negative 5 over 2. So at the end of the day, you have this particular value, which is r equals to 1 or our r equals to negative 4. Also, you can also use AC method. The way I explained in class, AC method is very simple. All you need to do is just to check, what will I multiply that will give me negative 4? And when I add it together, it will give me positive 3. So when we pick -4, which is our target, -1 multiplied by -4 multiplied by +1 will give us -4. But by the time we add it together, we are going to have -3. Addition will give us -3. But this one will give us -4, but addition will give us 0. So this one will give us -3. Addition will give us -3, that is the positive. So at the end of the day, by the time you have +4, -1 will give us -4 and +3. So then I can take here, I can also use r+4, r-1 equals to 0. By the time we solve for our r is either -4 or r is equals to 1. So our y complement in this case, the general formula for y complement are here. Then we can substitute our alpha, which is -4, 40, and t. So for us to now write our g of t, which is the other part of the equation of the question, is now that we have exponential and at the same time we have 16t. So all you need to do is just to split it into two. We have yp1 and yp1 and yp2. So yp1 will be for exponential 10 exponential t will be giving us a exponential t dot t plus and yp2 will be giving us bt plus c, because remember it's talking about the linear equation, that is like 16t plus 0. So remember 16t on its own is ax plus b. So now that we've used a, then we can change it to at plus bt plus c. So from then, when we add the two together, you have your yp in this format. Now we have the yp here. Then we can go ahead and differentiate yp. Differentiate yp to be what? The first yp you need to differentiate. Remember that you have at here, which means I'm going to use product rule for this point. I can I'm going to use product rule here, which means I can hold my a constant. I can differentiate at, which means I can say d dt of at, then hold et constant plus hold at constant and differentiate the exponential. So which implies that at means a exponential t plus, when I hold this one constant, I differentiate this one, I have at exponential t. So at the end of the day, we have this for this particular aspect, which means it's cater for this. Then when you differentiate bt, you have it to be b, and c will give us 0. Then you do the same thing for this. By the time you had this, a exponential t plus a exponential t will give us 2a exponential t plus at exponential t. So we go back to our general equation. Call it equation star or equation 1. It depends on the way you number your old equation. Then substitute your y prime, substitute your y prime into it. By the time you substitute it very well, so we're going to have, something like this, that is we're going to have something like this. Let me try and write it so that for the benefit of others, so we'll be able to see. So let me reduce this. It's going to be 2a exponential t plus at exponential t plus 3 in bracket. What is y prime? Y prime will be A exponential t plus at exponential t plus b minus 4 in bracket. What is my y? We can also look for y. We can also write the y. The y is the same thing as 4 in bracket y. A et plus our y will be at exponential t plus bt plus c equals to 10 exponential t plus 16t. So when you open the brackets, you have this. When you open the brackets, you have 2a exponential t like this. You have 3a exponential t plus 3at exponential t plus 3b minus 4at exponential t minus 4bt minus 4c equals to 10t equals to 10t plus 16t. So at this point, what we need to do is just to try to now link each of them with the coefficient of the, let's look at the first one. Which one has exponential of t? So we can collect the like terms. For example, those ones with exponential of t, I can say these 2a has exponential of t, right? 2a. Let's look at 3a is also have exponential of t. We add 3a. Then don't forget the coefficient of exponential of t in our equation is what? Is 10. So we put 10 there. Then the second one, a. The second one is we have those ones that only have 80. So we have the one with 80. Can change my marker. 80 will be this has 80. 3a also 380. We have it. And what again? Then this 480 also have. So we can collate everything together. Do we have anything equals to here? No. We only equate it to be 0 since we don't have any function D right hand side. So we have it a plus 3a plus minus 4a equals to 0. So now let's look at the b. Those ones that have b exponential t. Do we have anyone like that? No, we don't have. We only have the constant 3b and constant 4c. Then equate it to be 0 also. That is, constant 3b is there and constant 4c is here. So will be equals to 0. Will be equals to 0. Then there is one remaining here, which is now you can see this particular gentleman. You have negative 4bt. And don't forget the other side, we have 16t. So we can now equate the two together. We now have 4b, negative 4b equals to 16. So by the time you solve for b, we can easily solve for b here. When you said b divide both sides by negative 4. So when you divide both sides by negative 4, you have negative 4. So at the end of the day, I can also solve from equation 1. 3a plus 2a will give us 5a. Or that one will give us 5a. Then here we can get our b from equation 3, our c from equation 3. Substitute -4 there, you have -3. Then from equation 1 also, we can also get our a, 5a equals to 10, and a equals to 2. We have this. So since our y, we know our y from day 1, we can substitute it now. Now we have our constants, a, b, and c. We have them. So we can substitute them. So our yp will be equals to 2t exponential t plus multiplied by negative, we have -40 minus t. So this will be our yp in this case. So now if it is our yp, our general p, our general y is this. So our general y, before we use our initial condition, is very simple. All we need to do is just to substitute. So by the time you substitute yc and yp together, we have this. So it's going to be this. So when you have this together and it is equals to this, then that now gives us another privilege to be able to solve for so many things at the same time. It will give us another privilege to be able to do that. So in this case, we have general equation to be this. But that's not the end, because in this question, we're given initial condition that says y of 0 equals to 0 and y prime of 0 equals to 0. We've seen questions like that in your exam. So I will advise that we should also read the question very well before you interpret the question. So our general equation now, we can now differentiate the general equation. When you differentiate c1 exponential -4, you have it to be this. You have it to be -4. We have it to be -4 c1 exponential -4. Then plus, when you differentiate exponential, you have exponential. When you differentiate 2t, you have, now this one too, you have to be careful. This particular one, at this point, you have to use product rule to solve this one. Product rule. How do we use product rule? Hold one constant, differentiate 2t. When you differentiate 2t, you have 2. That's why you have it here. That's why you have it here. You have to multiply by this. Then all these 2t constants, that is it here. Then differentiate exponential, you have it here. Minus 40. When you differentiate 40, you have t, you have 4. So yeah, and when you differentiate 3, you have 0. So that's why we don't bother ourselves. Remember, the condition says y prime of 0 equals to 0. That is, at point of differentiation equals to 0, derivative equals to 0, like this, then t is also equals to 0. So anywhere you see t, substitute 0. Now we have -4 multiplied by 0 is 0. So we have this one to be 0 all through. And this particular one will be actually is 0. But exponential is 0 is equals to 1. So anywhere you see exponential raised to power 0 is 1. So substitute it here. So at the end of the day, we are able to realize that -4c1 plus c2 is equals to -2. It's equals to -2. Right. It's equals to -2. Thank you. So then that's not the end. Remember that the first initial condition says y of 0 is equals to 0. So it simply means, let's substitute where y is equals to 0, every other t is 0 too. Then at the end of the day, we are able to realize this. Now, let's substitute C1 into equation triangle. So when you substitute them, anywhere you see it, open the bracket. At the end of the day, you have C2 to be 14/5. Then we can now substitute our 14/5 in order to get our C1. So when you do that very well, it's very simple. Multiply both sides by 5, multiply it by, so we have 5, we have 15 minus 14, all divided by 5, which is equal to 1/5. So that's where we have 1/5. So we can now write our general solution in this format. A general solution would now be, now that we know our C1, we know our C2, then substitute them into your original y equation. So I believe this will help us. Also, these are part of the exam. We are in one of the questions in our exam says that we have the y is still the square y, the x square is the same thing as y prime prime minus 4y equals to 12x. Then we have the condition y of 0 is equals to 4. That is, when the y of 0 is equals to 4, y of 0 is equal to 4, meaning that y equals to 4, y x is equals to 0. Y prime equals to 1, y x is equals to 0. It's this one. So when you do this, try to represent this one also the way we do the other time. So by the time you represent it, your y will be equals to 0 or y equals to 4. So when you substitute them, by the time you substitute them, what do you have? So we have C1 because one of the c is equal to 0, exponential of 0 is 1. So you have it to be this. Now g of x is equals to yp equals to ax plus b. Differentiate your ax plus b. You have it to be a and you have it to be 0. So because when you are turned to constant, anytime it turns to constant is equals to 0. When you differentiate constant, you have 0. So at the end of the day, when you solve this one very well, so you are going to have, this is 3. So you are going to have this. Substitute your a. You have this. Open the bracket with -4. When you open the bracket with -4, you have this. And at the end of the day, we know our x, the other side we can say that is 12x. So which means 12 is equal to -4x, 4a. So at the end of the day, we have a to be 3, -3. A is -3. So if a is -3, it's okay. Then we substitute a, our b is equals to 0 automatically because everything equals to 0. When you divide both sides by -4, this is divided by -4, divided by -4. So you have it to be this. So our y is c1 plus c2 exponential 4x minus cx minus 3x. So now we have our condition, initial condition. Before then, we know our y to be this. When you differentiate y, you will have equation 2. So by the time I have equation 2, what next do I need to do? Substitute this x is equals to 0. Substitute x is equals to 4, y equals to 4. At the end of the day, we are able to realize that all these things are very similar and simple. So you have this. You have 3 plus exponential 2x. So like we are saying that at this point, several things needs to be considered. Let's look at this. So we have our general solution. After the general solution, we differentiate this, substitute into your y. Look at the way y is here, y prime is here. When you differentiate this, you have 0. When you differentiate this, you have 4c2 exponential 4x minus 3. The y of 0 is equals to what? Meaning s is equals to 0 and y equals to 4. So anywhere you see it, substitute it there. So you have c to be there, to have our c to be 4, c1 to be 4 minus c2. Then for the first derivative, you have your c2 to be 1, and substitute your c1 into this, you have your substitute your c2 to be this, so you have this. So the next thing we need to do is to look into y. We have y equals to c1 plus c2 and this. So this will now be our general solution. So now let's look at this in the context of when you have a trigonometric function. At the point of its trigonometric function, what is the yp when you have is either cos alpha x or sin alpha x? What is the particular solution of that? The particular solution for it is very simple. We say cos alpha x will be, we have it to be a cos. So we substitute the a, we substitute it into it. A cos alpha x plus b sine alpha x. Now, but we are dealing with cos 2s, so it will now change to this. Please take note. But we don't know a and we don't know b. So by the time you differentiate a, differentiate the yp, we have y prime p equals to negative. When you differentiate cos, when you differentiate cos, it turns to negative sine. So we have it to be this. When you differentiate sine, you have to be cos, 2 cos, because of what is there. Then when you differentiate the second time, you have, when you differentiate sine second time, you have cos 2x, which is negative 4. And when you differentiate this one second time, you have sine 2x, which is negative now. Cos to sine will be negative sine, so we have negative. So substitute them into original equation, which is this, which is equation star. When you substitute into equation star, we have this. We have, this is y prime prime, and this is 3y prime, and this is 2y. And we have our g of x here. So at the end of the day, when you open the bracket, all those that have cos 2s, all those that have cos 2x, let's mark them together. This has a cos 2s, this also have cos 2s. For negative 4a cos 2s plus 2a cos 2s will give us negative 2a plus, let's look at the one, another cos 2, yes, another 6b is here. So we'll take 6b here, then factorize cos 2s out. Then let's continue. We still have another one plus sine 2s. Let's look at sine 2s. Here is sine 2s, which is, here is, yes, this is negative 4b sine 2s plus 2b sine 2s. You have it to be You have negative 6a. Let's first of all take 6a. We have negative 6a. Then we have negative 2b. We have it here. We cannot add a and b together. They are separate. That's why we separated them. So sine 2x here. So equals to cos 2x. So from here, we can proceed. Now, let's compare our coefficients now. So for this particular one that I have cos 2s, remember, here is cos 2s, but we have 1 at the back here that we don't normally write. So we can say negative 2a plus 6b equals to 1. Equation 1. Then this particular one will be this is sine 2s, but we don't have sine 2s in the other side. So negative 6a plus this plus 2b will be equals to 0. Then let's solve for our b or let's solve our a. It depends on the one that is convenient for you. I think in this case, I can go ahead and solve for my b. So take this one to the other side, divide both sides by 2. So when I divide both sides by 2, I have my b to be what? Negative 3a. So, and I can substitute my b into my equation 1. When you substitute b into equation 1, you have this. So I can go ahead. Now I have this, open the bracket, I have 20a. So at the end of the day, when I have 20a over 1, 20a, negative 20a equals to 1. So that's what we have. So at the end of the day, you have a equals to negative this. And remember, we still need my b because b is not complete yet because I have b to be equals to negative 3a. Substitute negative 1 over 20 into it. This will cancel this. You have it to be what? 3 over 20. So you have this. So we can substitute our value. Let's say our yp is equals to what? Yp is equals to this. Let's substitute into yp. Yp will be, our a now is negative 1 over 20. Substitute it here. Then our b is 3 over 20. Substitute it here. So general solution, which we all know, is what? The general solution is C1 plus C1 exponential minus x plus C2 exponential negative 2x minus 1 over 20 cos 2x plus 3 over 20 sine 2x. So at the end of the day, we have this general solution to be this. So in the next class, we'll be looking at another interesting area that will also give us so that we look at the variation also, the example of variation before we move to other application. So before we move to other application, we will look at method of variation of parameters. Then after that, we can also check whether we have the applications of this particular area towards different aspects, probably the population model, the cooling, and so on. They are there in our manual also. Yes, application, they are right here now. Population model. We solved some question in the previous video. Please feel free to look at the previous video and solve some of those problems. It will help us and it will encourage you to see the application of what you've been doing. Then radioactive decay, Newton law of Cool. We need to check some application there. And that's end of the module for this particular one. Then we can now move to all these practice questions. You need to learn some of them and see how you can identify them. So thank you so much for coming, and see you in the next class. Bye for now.